Alrighty, so we're going to talk a little bit about error here. I think you could figure this out without watching the video, so I'd encourage you to try and do that. And I certainly don't want you to memorize these things. It would be better to just be able to draw little sketches. So let's try and figure out whether each of these things is an over or under approximation. So left-hand sums. So if a function is increasing, okay, and we cut it up into some subintervals here, and we use the left-hand side for each value, you can see that we're missing a lot of area. So a left-hand sum for increasing is going to be an underestimate, or under, I guess, gives an underestimate or under approximation, maybe would be a better way to say it, under approximation. Okay, now if it's decreasing, and we cut this up into a few subintervals, and we use the left-hand side, you can see that the left hand, if it's decreasing, is above the right hand. So that is going to give us an over approximation. Well, of course, if you have a right hand, the reverse is going to be true, right? If I have an increasing like this, draw some subintervals, use the right side, right? Now you are getting an over approximation. Whereas if you have a decreasing function and here's some subintervals and you use the right side, you are missing some area. So you're getting an under approximation. So increasing right hand over approximation, decreasing right hand is an under approximation. Again, do not try and memorize this. I don't have it memorized. I just am able to sketch it out and figure it out. Midpoint sums are a little bit on the tricky side. It has to do with concavity. So let's draw a little concave down situation here, or I guess we started with concave up. So maybe we better start with concave up. Concave up, and let's suppose that we have, just one subinterval here, and then what we're going to do is use this point right here as our height. So if that's our height, I guess in this case, it's really not too hard to see that that's an over approximation, right? I sort of chose, a nice example. You can see a midpoint in that case would definitely be an over approximation. What am I doing? That doesn't make any sense at all. Well, good for you to see that I don't always know what I'm doing. Whoops. Because we're finding area under the curve, right? So if this is my subinterval and it's concave up, right? I'm finding area under the curve, not above the curve. Silly me. Then I can see that my midpoint here is going to give me an under approximation of the area because I am missing this area right here. So if the function is concave up, midpoint sum is going to give me an under approximation. Similarly, if I have a function that's concave down, and let's say I choose this value and this value, here's my midpoint value right here. So if I draw that, you can see that I'm maybe missing a little bit of area there, but I've got way too much area over here. So way more area is being added than missed. So that means that if the function is concave down, a midpoint sum gives me an over approximation. Something very similar happens with trapezoidal sums. So let's say I have a concave up function, and here is my, let's say I go from here to here or something. Trapezoidal just connects these two. So you can clearly see that I'm getting more area than I should. I shouldn't get that area. So if the function is concave up, trapezoidal sum is an over approximation. Whereas if the function is concave down, and I find a trapezoidal, just by connecting these two, I'm missing some area, and therefore I'm dealing with an under approximation. Again, I would not suggest memorizing these, but rather being able to draw a picture and sort of figure it out from there. Left hand and right hand are quite straightforward. Midpoint and trapezoidal require a little bit more careful thinking.